In this video, we're going to go through how to give AI agents access to our Phoenix application. The purpose could be to implement a chatbot or expose some functionality for agent workflows. There is a new standard called Model Context Protocol, or MCP, that starts to get widely adopted today. So, in this video, we will implement a MCP server in a Phoenix application and demonstrate how to use natural language to retrieve and update data through an LLM like Claude or Codex. Let's add the Hermes package to our project. There are several MCP libraries available for Elixir, but Hermes gave me a good impression with its clean API and solid documentation. In the mix file, add Hermes to the dependencies list. Make sure you get the latest version since this is a new project and there is a lot of development going on in this space. To install the package, run the mix command in the terminal. Once this finishes, we'll need to restart our application to make sure all the new code is properly loaded. Now let's create our MCP server module. This will be the main entry point for this feature. I'm using Hermes.server to define our server with a name, version, and declaring that we support tools as a capability. The name and version here are arbitrary and public for the LLM-agent that will interact with us. A little later, I will register the tools we will expose, but I will circle back to that. We need to start our MCP server when our Phoenix application boots up. The MCP server runs as its own process within our application's supervision tree, just like our database repo or PubSub. In the application module, I need to add two new children. First is the Hermes server registry. This keeps track of all running MCP connections. Then, our actual MCP server, configured with the streamable HTTP transport. There are different transport protocols available, but streamable HTTP is perfect for our needs, since it works well over standard HTTP connections. With these in place, our MCP server will start automatically when Phoenix boots and be ready to accept connections from AI assistants. Since this is exposed to the outer world, I also need to set up routes. Here in the router file, I'm creating a dedicated pipeline specifically for MCP requests. This pipeline is different from our regular browser or API pipelines because MCP communication works through a combination of JSON RPC messages and server-sent events. That's why you see it accepting three content types: JSON for the structured tool calls and parameters, SSE, and text/event stream for the streaming responses that flow back to AI assistants. With the pipeline in place, I'm defining a new scope under the MCP path and use the pipeline we just created. This forward directive takes all incoming requests to /MCP and hands them off to the Hermes streamable HTTP plug. This plug handles all the complex MCP protocol details for us. Before we can make this work, we need to extend the web server and define a new MIME type that Phoenix doesn't allow by default. So here in the config file, I'm adding the text event stream MIME type configuration. Now let's fire up the server and see if our MCP integration seems to be working correctly. If it starts without warnings, we can assume everything is correct so far, and that all the pieces we've put together seems to work correctly. As you can see, we have a new set of debug messages, and we can specifically see that the MCP server is starting and is indeed pointing to the MCP module we made. However, at this point, even if it started, it doesn't have any actual functionality. Let's fix that now. By functionality, I mean specific tools that an AI assistant can use. So, we will create the first tool that lists breweries. Here in our new List Breweries file, I'm using Hermes server component to define the tool structure. The module doc is important. It is public and tells the AI assistant what this tool does. Since listing all breweries doesn't require any parameters, our schema block stays empty. The real work happens in the execute function, where we fetch all breweries from the database and map them into a clean JSON structure. Notice how we're returning a response that includes both the breweries array and a count. This structured format makes it easy for AI assistants to understand and work with the data. The MCP protocol handles the rest through Hermes. Before the new tool is ready, it needs to be mounted in the MCP server. This is just a one-liner to add. Now it's time to test our MCP server and see if everything is working correctly. The easiest way to do this is by using the official MCP inspector tool, which is specifically designed for testing and debugging MCP servers during development. I can start the inspector directly from the terminal using npx. This command will download and run the inspector, which gives us a nice web interface for connecting to our server and testing all the tools we've built. Perfect! The inspector is now running and has given us everything we need. It started a proxy server on localhost port 6277 and generated a session token for authentication. Most importantly, it's provided us with a complete URL that includes the authentication token, so we can jump straight into the inspector interface. Let me copy this URL and open it in the browser. So, this is how the inspector looks when it's open. Before connecting, I need to configure some default settings. First, I'll change the transport type to streaming HTTP, matching what we specified in the application. Then, I'll set the local host port to 4000, the same port Phoenix server is running on. Notice we're pointing to the /MCP route. Now I can connect to the server and list the available tools. Here's list breweries, and when I run it, you can see it returns successfully with 31 breweries. Okay, we have something that works. Let's build another tool that retrieves a specific brewery by its ID. While the list tool gives us everything, this one lets AI assistants focus on a single brewery when they need detailed information about a particular location. And as before, the module doc tells the AI assistant what this tool does. Now this tool requires parameters. Our schema defines a required integer field for the brewery ID. This tells the AI it must provide an ID when calling this tool. The description helps the AI understand what information it needs to provide. In the execute function, we're taking that ID parameter and querying our database for that specific brewery. We then map it into the same clean JSON structure, returning all the brewery details. Okay, there's one last tool I want to add. It's the update brewery. And I'll make a new module and we're following the same pattern, but this time, our schema includes multiple optional parameters. The ID is required to identify which brewery to update, but fields like name, city, state, and phone number are all optional. This means the AI can update just the name, or just the phone number, or any combination it needs. In the execute function, we first fetch the brewery by ID. Then we filter out any nil values from the parameters, since we only want to update the fields that were actually provided. When we call update brewery, we're leveraging our existing Phoenix context, which already has all the validation logic built in. If the update succeeds, we return the updated brewery data. If it fails validation, we return a structured error with the change set errors so the AI assistant knows exactly what went wrong. And once again, I need to update the server and add our two new tools. I also need to restart the server after this. All right, now that we have the tools in place, we can switch back to the MCP inspector. First, I'll reconnect to the server to make sure the connection is active. From here, I can list the available tools, and there they are. List breweries, show brewery, and update brewery. Let's start with the show brewery tool. I'll pass in the ID 31 and run it. Perfect, we get a single brewery back, with all its details returned from our Phoenix app. For the last test, I'll use the update brewery tool. Once again, I'll select brewery 31, and this time, I'll change the name from Loveland Loggers to Loveland Brews. After running the tool, the update goes through successfully, confirming our server is fully connected and handling both reads and writes through the MCP interface. Fine! It works in the inspector. Let's wire this up to Claude code so we can see our MCP server in action. I'll add the server using the Claude MCP add command, pointing it to our local Phoenix server, and specify that we are using HTTP transport. The word tutorial here is just an arbitrary name that is required, and we can use to reference this if we have multiple MCP servers connected. Now I can ask Claude to use the tool to find all breweries in Boulder. Perfect! It found 3 breweries, all with their complete details pulled directly from our Phoenix application through the MCP interface. For our final test, let's make an update. I'll ask Claude to update the phone number for that third brewery, Flatirons Brews. And, just like that, the update goes through successfully. Our AI assistant just had a natural conversation with our Phoenix application, querying data and making changes using the standardized MCP tools we built. So there we have it, a complete MCP server running inside Phoenix that gives AI assistants direct, standardized access to your application's data. You can now have conversations with AI about your data, ask them to find patterns, update information based on natural language requests, or build complex workflows that combine multiple tool calls.